The hunt for interesting exoplanets and life forms somewhere out there in the vast expanse of the universe keeps going. No stopping here. We're basically searching for a second Earth, a planet that's similar to our home and where we could finally find some space friends. We're not picky. Any form of life is fine, even some bacteria-sized organisms. And this search has mostly been going on in the habitable zone around other stars. We also call this the Goldilocks zone. That's a region where conditions are barely just right for liquid water to exist, whether we're talking about the surface of a planet or a moon. The hotter the star, the more space we get to explore because its habitable zone spreads far away. And in terms of endless space that we yet know so little about, that's a lot of work. That's why we're fans of red dwarfs. There are hundreds of billions of stars in our galaxy, and probably around 80% of them are red dwarfs. These tiny stars are much cooler than our sun. It means that their habitable zones are much smaller and closer to the star, so we know better where to look for planets. They're circling around their central star, and at some point, bingo, there it is. They pass in front of it and block out some of its light. The Kepler Space Telescope has already helped us find thousands of planets using this method, and most of them are orbiting around red dwarfs. Some of these planets are similar in size to Earth, and many of them could have nearly 25 times more water than our entire planet. Let's move to these planets scientists discovered though. I want to show you something special. So you've heard of super-Earths, right? More massive than Earth, lighter than Neptune, can be made of rock, gas, or a mix of both. Some of them have thick atmospheres, while others have thin or no atmospheres at all. You may have also stumbled upon mini Neptunes by now too. They're almost as big as Neptune, and unlike normal gas giants, they have solid cores. That way, they can support a dense atmosphere with water and some other chemicals necessary for life. There are also hot Jupiters. Those are pretty cool, but only if they're far away from us. You know that one annoying and unpredictable neighbor you can never get rid of or figure out what they are going to do? Yeah, that would be a hot Jupiter, with strong gravity that can destabilize the orbits of smaller planets or other space bodies in the system. If we had such a neighbor, there would be more comets and asteroids hitting our surface. Luckily, our Jupiter's a good and peaceful neighbor that minds his own business, at least for now. But let's leave all these and many other planets out there alone now. Imagine traveling around in your spaceship and coming across a giant eyeball just floating there in the darkness of space and staring at the central star of that solar system. It's not a monster. Hopefully, space friends we'll make in the future won't look that big and scary. So, it won't blink or turn toward you as you come closer. It's actually a planet, a little bit bizarre but still very cool. And yup, you guessed it right, we call such eyeball planets. Eyeball planets are surprisingly common. Plus, some normal planets can potentially turn into them too. Eyeball planets form when matter and dust accumulates around a star and gradually turn into a solid object. It starts spinning. And over time, the gravity of the star pulls on the planet and slows its rotation until it becomes tidally locked. That means one hemisphere always faces the star, while the other is in darkness all the time. We have a good example of this phenomenon near us, too. Our moon makes a circle around Earth once a month. It takes the same amount of time to turn a single time on its axis. That way, we actually always see the same face of the moon. Who knows, maybe the other side is even prettier. If you know, you like craters and stuff. So, one of the most interesting things about eyeball planets is their appearance. If they had water on their surface, the side facing the star would have clear, bright blue oceans, the ones we'd want to visit if we ever got a chance to go on an interstellar vacation. And the other side would be more for adventurers who like harsh and challenging surroundings. Since it's in constant darkness, it would most likely be very cold and covered in ice. We've discovered so many planets outside of our solar system in the last 30 years. Super-Earths are, of course, especially interesting. It seems that many of them are not that pleasant since they're pretty hazy and cloudy. It means it's harder to spot any life there. but some scientists still think they're promising spots when it comes to finding life beyond our solar system. Eyeball super-Earths would be a good start. These planets are probably covered in large oceans. On the cold half, where the eternal night reigns, you'd experience Arctic conditions. Brr, I feel cold just looking at this, but the day side is my jam. Plus, it sounds promising when it comes to finding life, you know, with all that sunlight, oceans, and stuff. One of the good examples where scientists are looking for life is an eyeball super-Earth that lies in a habitable zone of the closest star to our solar system, called Proxima b. Its day side could even have conditions and an atmosphere to support some form of life. There could be a large, deep ocean covering its surface. It could be really salty, but some forms of life could still survive there. Check out the Dead Sea on Earth. It's extremely salty, but some bacteria have still evolved to live there, and they're probably doing well, having their own world and all that. I mean, it's not crowded because there are no animals there. Fish that accidentally end up in the Dead Sea won't survive there for long. So, similarly, it's possible that bacteria or some other forms of life could exist in this potentially very salty ocean on Proxima b as well. But the open ocean on Proxima b could be tricky. On the dark side of the planet, the ocean could freeze and sea ice could drift into warmer waters. That way, the ocean would cool and more of it would freeze, even on the sunny side. The only way to prevent this global freeze-over would be an atmosphere with a lot of greenhouse gases like carbon dioxide. This kind of atmosphere would trap the heat from the planet's surface and wouldn't allow it to escape into space. Like what happens with Venus, the hottest planet in our solar system. Without an atmosphere with greenhouse gases, the surface of Proxima b would be much colder, so it's possible that the planet would completely freeze over. The opposite scenario could also be possible. Warm waters could serve as a transporter of heat from warm to cold regions. We don't know much about the conditions on the planet yet, so Proxima b could range from a frozen wasteland to a hot, hazy world, depending on many factors. So yeah, an eyeball planet within the habitable zone sounds promising, but its surface can still wildly range from a frozen desert to an endless ocean. Some experts believe that drifting sea ice might cool many exoplanets out there, and they can't turn into eyeball worlds. Instead, many just become sad, dark snowballs, completely covered in ice. A cool spot to spend your interstellar winter holidays, but not a place where you'd hope to find life, unfortunately. Some studies show that even Earth may have gone through some snowball stages many times in history. One of those happened around 2.2 billion years ago, while the other one hit the planet 630 million years ago. During these phases, all of our beautiful oceans were covered with snow and sea ice. Perhaps even the continents were just thick ice sheets, at least on the surface. Alright, enough with the freezy, icy stuff. I need some hot chocolate. Stargazers, come up here, cause I have exciting news. Astronomers have just completed the full mapping of 2 pairs of stars outside our Milky Way galaxy that are chowing down on their stellar neighbors. Not only does it give us a better understanding of stars in general, but it can also help us measure distance in the night sky. Did you know that more than half of the stars in our Milky Way are paired? And while it's likely that other galaxies have a significant number of binary stars too, they're usually too faint to see. But these so-called symbiotic stars, where one star consumes the other, are extremely bright and easier to observe. And according to scientists, measuring the orbits of these symbiotic star systems is an essential step toward learning whether other galaxies create binary stars like those in our Milky Way. Now, let's get down to the nitty-gritty. A pair of stars may be born together, but due to their masses, they age differently. The more massive one burns through its material faster, reaching the end of its lifetime first, and leaves behind a compact white dwarf. White dwarfs are small and dim, but can pack the mass of the sun into an object the size of Earth. If close enough, their gravity can pull material from their companion, creating a signal that astronomers can identify from far away. Draco, Draco, C1 and Lin 358 are the symbiotic stars that have been fully mapped. The stars in Draco C1 take roughly 3 Earth years to orbit one another, while Lin 358's components take just over 2. These are the first full orbital measurements of any symbiotic star system outside the Milky Way. The new measurements will help astronomers better understand star formation in other galaxies. In some symbiotic stars, the white dwarf can slurp enough material from its companion that it explodes in a supernova. These supernovae are incredibly bright and can be seen across the universe. They all start out with the same brightness for a nearby observer, making them like a sort of standard candle for measuring the universe. While Draco C1 and Lin 358 are unlikely to explode as supernovae anytime soon, understanding how they work can provide us with a better understanding of how these standard candles evolve. If you're here to complete your knowledge of weird stars in the universe, don't be disappointed. We're not finished just yet. Have you ever wondered about the biggest stars in the universe? Scientists have recently discovered a gigantic star called UY Scuti. This bad boy is located about 9,500 light-years away from Earth and is truly out of this world. It's about 1,100 times larger than our Sun, which means if it were in our solar system, it would reach past Jupiter's orbit. There's more. UY Scuti isn't just massive, it's also super bright. It's what scientists call a red supergiant, and it shines with a brightness of about 340,000 times that of our Sun. If you're thinking about getting a tan from this star, think again though, it's way too far away for that. How does a star like UY Scuti even form? You might wonder. Well, it starts out like any other star. A cloud of gas and dust collapses under its gravity and starts to heat up. Eventually, the temperature becomes hot enough in the core of the cloud to ignite nuclear fusion, and a star is born. But UY Scuti didn't stop there. It kept devouring more and more gas and dust, growing larger and larger. This process continued until it became the giant we know today. As fascinating as UY Scuti is, it's not the only big star out there. There are others like VY Canis Majoris, Canis Majoris, which was once thought to be the biggest star until UY Scuti stole the show. VY Canis Majoris is still a force to be reckoned with though. It's about 1,400 times larger than our Sun and located about 5,000 light-years away from us. But here's the kicker. Stars like UY Scuti and VY Canis Majoris aren't even the biggest things in the universe. Not by a long shot. There are objects called hypergiants that make these stars look like ants in comparison. One such hypergiant is Stephenson 218, located about 20,000 light-years away. It's about 2,150 times larger than our Sun and shines with the brightness of 7 million suns. And just when you thought things couldn't get any crazier, there's a mysterious object called the Great Attractor that's pulling everything in our local group of galaxies towards it. We don't know what it is or what's causing it, but one theory is that it's a massive cluster of hypergiants. We'd be minuscule in comparison. This next star is so metal, it's practically headbanging all the time. Jokes aside, scientists have discovered a star that's called a heavy metal subdwarf. It's a type of star that's seriously metal heavy. This star has more metal in its composition than any other star we've seen before. Such stars are said to contain metal elements like iron, nickel, and chromium. This heavy metal subdwarf has about 10,000 times more iron than our Sun. In their discovery, astronomers used a technique called spectroscopy, which involves analyzing the light that comes from the star to determine what elements it's made of. By looking at the spectrum of light, scientists were able to see that this star had an unusual amount of metal in its composition. There's more. This heavy metal subdwarf isn't just a regular star with a lot of metal, it's also really weird in other ways. For one thing, it's smaller and cooler than our Sun. And for another, it's really old. We're talking about a star that's been around for almost as long as the universe itself. What does this all mean? Well, scientists are hoping that by studying this heavy metal subdwarf, they can learn more about the early universe. Since this star is so old that it was around when the universe was just beginning to form, it's seen a lot of stuff. By studying its composition and characteristics, scientists can get a better understanding of what the universe was like in its early days. This next star is one of the coolest things in outer space. Her name is Vega, and it's one of the brightest stars in the night sky. Some recognize it as the shiny point of light in the constellation Lyra-Lyru. And get this, it's only about 25 light years away from us, which in astronomical terms is practically next door. Scientists have been studying Vega for a long time, and they've learned some pretty interesting things. For starters, Vega is a young star, only a few 100 million years old. That might sound like a long time, but compared to our Sun, which is around 4.6 billion years old, Vega is practically a newborn. Vega is also a very hot star, with a surface temperature of around 9,400 degrees Celsius F. To put that into perspective, the surface of our Sun is only about 5,500 degrees Celsius. So, if you think it's hot outside today, just be glad you're not hanging out on Vega. Another interesting thing about this star is that it's surrounded by a disk of dust and gas. This disk is called a debris disk because it's made up of leftover material from when the star formed. Scientists think that this debris disk is similar to the one that surrounded our solar system when it was young. Vega is also a source of cosmic rays. These rays are high-energy particles that zip around space at incredible speeds. They're made up of protons, electrons, and other particles, and scientists aren't exactly sure where they come from. But they do know that Vega is one of the places where cosmic rays originate. But wait, there's more. Vega is also a famous star in pop culture. It's been used in a lot of movies and books as a source of inspiration, mostly because of its brightness and cool features. It's hard not to wonder if there's another form of life out there in the universe when you, at the night sky. There's this thing called Fermi paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We've looked really hard, but we haven't stumbled over any proof there are other forms of life somewhere in space, and we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, Fermi paradox basically asks, where's the party? How come we weren't invited? See, and one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, Robin Hanson, 1996, and it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face, the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development, and then something happened that destroyed them, like an asteroid impact or an environmental disaster, or they could cause their own demise, and bam, everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Woohoo! But it would also mean that intelligent life is relatively rare in the universe, and that we may be the only advanced civilization that exists at the moment. So the universe could really be relatively empty when it comes to intelligent life. That means the chances we'll make some friends from other planets and visit them in our super cool spaceships are low. That's sad, but the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really lies in our future, it may mean that there are many intelligent civilizations out there, but they are all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter theory talks about is the development of artificial intelligence, AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity or lead to unwanted consequences if we're not careful enough with it. There's still hope though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers believed it was just a plain rock covered in ice. But in 2005, NASA's Cassini spacecraft took photos of geysers of frozen water that was spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is the key element for the development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And it plays a very important role in many biological processes, e.g. cell membrane formation, energy transfer. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life: Titan, Enceladus's big brother. It's the only moon in our solar system that has clouds and a dense atmosphere you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes filled with methane and ethane, liquid natural gas. But still, Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the sun though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. We can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They have also found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap, and scientists believe it could even contain microbial life. Europa is one of the moons that orbit Jupiter. It potentially has plenty of water too. There could be a salty ocean under its nearly 10 miles thick crust, with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth, so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield, so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geologically inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the moon formed, which is why it gives us a unique window into the early history of the solar system. And you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh? Black holes are some of the most enigmatic and sinister phenomena in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Let's have a look-see, okay dokie. So, a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans: petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when a massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of the collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and the mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon, then there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be, which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll be eventually sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled towards the black hole, triggering a massive windstorm, and there'd be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans get stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions. As the planet's crust and mantle were pulled apart, all infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't even have seen all that, because you would have felt the effects of the black hole much, much earlier. Back to the future. We'd lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'd also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a gob of putty. And yeah, all this is scary to even imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better that the Earth will ever be swept into a black hole. The nearest black hole to our solar system is called Gaia H1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia H1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of threat. Hey, but didn't you say that there's a black hole in the center of the Milky Way? Doesn't that mean it's going to eventually hoover up our entire galaxy? You may ask. Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes, and even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now I think I'll turn my attention to the incredible power of chocolate. A recent study has involved almost 200 huge stars that are reaching the end of their lives. It has given scientists more precise information about how the sun will one day end. It turns out that the sun will be about 200-300 times bigger than it is now by the time its game is over. For starters, let's begin with some basic information about star sizes. Giant ones reach this stage because they've run out of nuclear fuel and are no longer burning hydrogen in their core. Eventually, the core gets hot enough to trigger the next stage of fusion, which is helium burning. All the stars that were surveyed in this new study were either in this hydrogen shell burning or helium core burning phase. Even though giant and supergiant stars only make up less than 5% of all stars, or at least that we know of, they're actually really visible from a distance because they're so bright. In fact, according to scientists, about a third of all the stars you can see outside on a dark moonless night are giant or supergiant stars. This study will eventually give astronomers really useful info about massive stars. They'll be able to figure out their size and temperature, no matter where they are or their evolutionary stage. This means they can see a star's true color and use that to find out its radius. Pretty cool, right? It does raise the question, what will our sun be like when it gets old and grumpy? To put it simply, it will expand when it starts burning its hydrogen shell, but then shrink a bit during its helium core burning phase. After a few 100 million years, it'll end up as a giant star about 200 to 300 times its current size. Eventually, the sun will expand so much that it will simply evaporate. So, what will happen after the sun fades away? Scientists actually have some predictions about what will go down, even though we won't be around to see it. They're pretty sure the sun will turn into a planetary nebula. These planetary nebulae are chunks of gas and dust in space that come from a star that is fading away. They got their name because they looked like planets to people using telescopes back in the 18th century, even though we now know they have nothing to do with actual planets. But here's the crazy thing. Astronomers have found out they can use the level of brightness of these planetary nebulae to calculate their distance from us. In 2018, scientists also found out that the sun is the smallest a star can be to still be able to produce a visible nebula. Any smaller, and it would not be visible. Stars that are up to 3 times more massive than the sun will produce brighter nebulae. The sun is currently 4.6 billion years old, but it's estimated to have another 10 billion years until its end. The sun is also getting brighter with each year. It doesn't seem like a lot now, but it's actually going to cause some big problems for Earth. In about 1 billion years, the sun will be too bright for life on Earth to survive. Our oceans will evaporate, and it will be too hot for water to form again. So, unless we find a way to escape from this planet, humanity only has about 1 billion years left. Will Earth still be around by the time the sun turns to dust? It's hard to know for sure the exact timeline, but even before that happens, Earth will most likely be scorched and lifeless, with no atmosphere or oceans left. It's not clear how close the sun's outer layers will get to Earth, but if they get too close, it could cause Earth to spiral into the sun and disappear altogether. Even if our planet does somehow manage to survive the sun's giant phase, it will be orbiting a hot white dwarf, or a star that has run out of its fuel. In that distant future, the sun will be barely larger than our planet. Eventually, the sun will cool and dim completely. It'll move to another stage called a black dwarf. It will cause Earth's orbit to loosen up, and our planet will spiral into the faded sun. But interestingly, the sun doesn't get the final say in what happens to Earth. Gravity keeps planets in orbit, but it also attracts them to each other, which can cause their orbits to flex and drift. This could lead to the solar system destabilizing and ejecting planets, including Earth. Basically, a lot might happen in the next 5 billion years before the sun becomes a red giant. There's also another scenario. While most stars stay far away from our solar system, there's a chance that one could come closer in the next billion years. Even a small star or black hole could mess up the orbit of our planet if it gets too close. But don't worry too much. The odds of that happening are low because of the amount of space between stars. Our sun is a solitary star, so there's little to no chance we'll be able to catch a ride with another one nearby. However, many stars in our universe have companions. Among these stars is Castor, a stunning system that comprises 6 stars and is one of the brightest objects in the night sky. Although humans have been admiring Castor for ages, they were not aware of its true nature until the invention of telescopes and spectroscopes. Even with the help of a small telescope, it's evident that Castor is composed of 2 primary stars, Castor Ia and Ba, that revolve around each other. These stars are larger than the Sun and need 467 years to complete one orbit. In total, Castor is composed of 6 different stars. The biggest one, called Castor Ia, is roughly 2 times larger than the Sun, while the smallest has about 0.5 of the Sun's mass. If humans want to survive the next billions of years, we might need to set up camp somewhere else in the universe. It may seem like something out of a sci-fi movie, but it could be our reality one day. Thankfully, NASA is already looking at some options. They've discovered 2 new planets, TOI 700e and TOI 700d, that might be new hotspots for us humans. TOI 700e is in the optimistic zone, which means it could have water and even an atmosphere. TOI 700d is in the conservative habitable zone, so scientists aren't too sure about it yet. But hey, we'll take what we can get. But hold on. Before you start packing your bags, there's a little problem. How do we get there? It took John Glenn months of preparation just to circle Earth 3 times, so we might need to start working on our astronaut training. Well, at least we have some options for our future intergalactic vacation plans. Wouldn't it be nice if we could time travel so we could see what our solar system will look like in billions of years? An American physicist named Ron Mallett has proposed one interesting theory for time travel. It uses light, a resource that is abundant in the universe. His idea involves using a rotating cylinder of light, which could transport an object in both space and time, similar to how a bubble moves in a swirling liquid. Mallett suggests that a cylinder of the right shape could allow for travel to the past and the future. To test his theory, he has been trying to secure funding for an experiment. However, some scientists consider Mallett's theory to be impossible and unnecessary to test. We might also be able to travel through time if we move fast enough. According to Einstein, the way we experience time can change depending on how fast we're moving. If we go really fast, time slows down. For example, astronauts in space age a tiny bit more slowly than people on Earth. This is important for things like GPS, which would be incorrect without special adjustments because of how time is affected. Space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green, but because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas made mostly of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy, and that's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans. A spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So technically you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope. You won't turn into a popsicle right away. It's going to take a bit longer than that, because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then, after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out. So all those epic space battles and galactic explosions would be completely silent. Yet, there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free falling around the planet. And let's be real, Hollywood's version of space travel is not the fact. Sure, orbits are a thing, but different altitudes mean different speeds, so moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added up some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lee. It's zooming through space at a speed of 140 mph, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket because that would be one astronomical fine. Without the sun, planets would be pretty chilly. We're talking temperatures as low as 455 Ross Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things, like the planet's size and reflectivity, also come into play. So, Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe, and there's still so much we have yet to discover. Who knows? Maybe one day we will really discover little green people out there, or maybe we'll find something even more incredible. Until then, we'll just have to keep dreaming and exploring. There you got 14 things on our list. Do you have any other space myths to debunk? Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases, like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing: oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms like algae and bacteria rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Maniitsoq crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now, that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam. It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now, here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match, and voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during this second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say oxybummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organism started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today, about 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys. Asteroids flying around is sometimes like a fierce game of dodgeball, where you never know when some of them can go in your direction. So we can just track the situation and hope for the best. To figure out the risk, scientists from different organizations have to study the positions and paths of the asteroids that come close to our planet, especially those that are at least 0.6 miles wide. And the good news is that none of these asteroids will probably hit us for at least the next 1,000 years. Phew. To give us an idea of their power, scientists did an experiment to simulate the impact of such a gigantic asteroid. The energy released from the collision would be a mind-blowing 100,000 megatons. That's like detonating 15,000 tons of dynamite. Also, if such a big asteroid hit us, Earth would cool down significantly because of all that debris that would go into the atmosphere and block sunlight. Plants wouldn't be able to get their fuel in this case, so we'd all be in trouble, both humans and animals. Thankfully, such mammoth asteroid impacts are quite rare. The larger an asteroid, the longer it takes it to collide with Earth. For example, it's estimated that asteroids with diameters of at least 0.6 miles strike our planet about once every 700,000 years. And if we're talking about even bigger ones that are 3 miles wide, well, those are predicted to come crashing down only once every 30 million years. Yay! But hold on, don't get too relaxed just yet. Astronomers focus on really large asteroids because those are the ones that can kinda doom our planet if they hit us. Yup, you got it right, in a dinosaur kind of way. Even if one of them didn't erase us completely, the damage would still be enormous. So there are still some asteroids wandering around that we need to keep an eye on to see how they might evolve over time. Scientists have a model of tracking them, where they focus on the parts of an asteroid's path that come close to our planet to see if the space rock poses a risk to us. And it seems there might be one asteroid, 7482, 1994, PC1, 3,600 feet in diameter that might pose some danger. It's supposed to come closer to our planet in the next 1,000 years. And when I say risky, it means there's a 0.0151% chance of it coming within one Earth-Moon distance. It already passed by us in 2022, but we were lucky because it was far enough 1.2 million miles. I'd say we can relax when it comes to asteroid scenarios, for now. Asteroids slamming into Earth would be new for humankind, but not for the planet itself. As I said, there weren't many of those big ones, but they still had enormous consequences. The first one that comes to most people's minds is, of course, the dinosaur asteroid, as big as a mountain, that struck our home planet around 66 million years ago, near Mexico's Yucatan Peninsula. It was chaotic. Global firestorms and tsunamis were all over the place. Dust was blocking out the sun, and vaporized rock released sulfur, which then led to acid rain and the acidification of the oceans. But there was an even bigger fella that came before that one. Around 2 billion years ago, a gigantic asteroid crashed into our planet and left a massive crater in South Africa, the one we know today as the Vredefort crater. And it seems this asteroid might have been even bigger than we all originally thought, twice as wide as the space rock that erased dinosaurs. The Vredefort crater is confirmed to be the biggest visible crater on Earth, with a diameter of about 99 miles. It used to be even bigger when it first formed though, maybe even 155 to 174 miles across. It's hard to figure out its true size because the crater has been eroding for the past 2 billion years. Think of it like slicing off layers from the rim of a bowl. The diameter gets smaller with each slice. When the asteroid, 7.5 miles wide, that wiped away dinosaurs hit Earth about 66 million years ago, it caused massive destruction. Forest fires, acid rain, tsunamis, and so much ash and dust that it changed Earth's climate. This all made about 75% of life on our planet extinct. The asteroid that created the Vredefort crater was not only bigger, but it also traveled at a higher speed, which means the consequences there would have been even worse. But it happened a long time ago, and living beings were different back then. Maybe it was some bacteria that didn't even notice that something unusual was happening. Earth is not the only one. Lots of impacts have happened across our solar system too. For example, in our close neighborhood. Yup, moving to Mercury and its massive crater called the Caloris Basin. It measures about 950 miles across, which is more than the state of Texas. There's a ring of towering mountains around the crater which makes it look even more impressive. You can see different colors in the mosaic image of the Caloris Basin. They tell us more about the geology of the basin. The orange parts represent lava that once flooded the basin. These lava flows covered the original surface and added this specific orange hue. And after the lava flooded the basin on Mercury, smaller craters formed on top of the lava surface. These craters dug into the ground and uncovered the material hidden beneath the lava. Some of this material is blue in color, and this blue stuff could be a clue about what the original floor of the basin had looked like before the lava covered it. Venus, the hottest planet in our solar system, has a thick atmosphere that comes with a pretty good defense system against space rocks. It's so dense that it burns up most meteors before they even reach its surface. As a result, you won't see as many visible craters on Venus as on other rocky planets in our solar system. But Venus still has some scars that can tell us about some serious impacts that happened there, and one of the biggest scars we know about is Meade Crater. It's enormous, about 170 miles in diameter. The inner floor of this crater is relatively flat and kind of brighter than its surroundings. It's possible that the crater ended up filled with a mixture of melted rock after the impact, and maybe even lava from volcanic activity on Venus. Want to get an idea of what Earth might look like without its protective layer called atmosphere? Just take a look at the moon. Its surface is littered with impact craters. This Tycho is one of the craters you'll easily notice on the moon. When you look at the full moon, you can spot it as a distinct circle with bright rays that radiate outward, slightly off-center on the lower left side of the moon. This crater, 53 miles wide, has a beautiful central peak in the middle that's topped with an intriguing boulder. The size of this boulder is impressive. It would fill about half of a typical city block here on Earth. When talking about craters, we definitely can't leave out Mars. The red planet has a much thinner atmosphere than Earth. When spacecraft approach Mars, they rely on the planet's atmosphere to slow them down as they enter it. And indeed, the atmosphere helps slow spacecraft down during landing, but it's still not thick enough to completely protect Mars from all those space rocks that are coming all the time. From July to September 2018, a dark spot appeared on the southern pole of Mars. It consists of two distinct patterns. A theory says that the bigger, lighter-colored blast pattern can be the result of an impact shockwave scouring the ice surface. The impact generated winds that spread out and scoured the ice. The inner blast pattern, which is darker in color, occurred because the impacting object managed to penetrate the thin ice layer. As it hit the surface, it sent dark sand and debris flying in all directions. Ah, what a nice cosmic family! Meet Mars. I bet you've met him before. These two little guys are Phobos and Deimos, Mars's small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 30-50 million years. I won't be around then, so I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the red planet. But wait, there's more. Phobos has these crazy parallel grooves all over its surface. We used to think they were from an asteroid crash, but now scientists think they're actually from Mars' intense gravity pulling the moon apart. Talk about a rough ride. Scientists have this wild idea that when a little guy, like Phobos, gets too close to a big guy, like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry at the rate Phobos is going. It's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we will still have the chance to learn more about Phobos. NASA just picked 10 rockstar researchers from all over the US to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the 2 Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles. To be precise, that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral towards Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Okay, so picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the red planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planets. It's like if you were wearing nothing at a depth of the Mariana Trench. If it was possible, you'd be defenseless. And chilly, that's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen. Not a good idea. But at least we can learn from Mars' mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the red planet isn't mean at all. It's actually pretty friendly. While Mars seems to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, a team of scientists found a way to grow rice on Mars. Yeah, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. But here's the catch. Martian soil has these nasty perchlorate salts that can be toxic for plants. So, the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of perchlorate per kilogram. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So, the team decided to mix a quarter of potting soil with the Martian simulant. And looky there, the plants started developing better. Now, these scientists aren't just thinking about feeding Martians. They also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when two researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you have to ship insane amounts of water from Earth, as it's not easy to quench this plant's thirst. You're right, you need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists just made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars' equator. That's right, water ice on Mars, even near the equator. This is huge news and could mean that there's even more ice just below the surface. It's not just any glacier, it's a relict glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. That's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come in contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe one day we'll even get to visit that salt glacier statue in person. See you next time. For decades, people have been dreaming of exploring space, and since the year 2000, there has indeed been a continuous presence of people in space. And recently, a new record has been set. Just a couple of weeks ago, there were 17 people from 5 different countries in Earth's orbit at the same time. The previous record was set in September 2021 during the privately funded Inspiration 4 mission. At that time, the number of people in orbit reached 14. So, let's see. Just recently, 3 more people have arrived at China's Tiangong space station. Pronunciation https://www.youtube.com/mp3udwlbtk. There are 3 more astronauts aboard the same station, but they've been there since November 2022 and are supposed to return back to Earth in June. Then there are 7 people on board the International Space Station, and 4 more people departed the ISS aboard SpaceX's Crew Dragon named Freedom. They successfully returned to Earth on the 30th of 2023, leaving 13 people in orbit. Interestingly, the current record also includes the 600th person to get to Earth's orbit, specialist Rayana Barnai from AX-2 mission became space traveler number 600, as well as the first Saudi woman in space. But I've got something even more exciting to tell you. Oh my! The record for most people in space, and not just Earth's orbit, was reset not so long ago too. But it lasted for a mere 5 minutes or so. But during this short period of time, there were 20 people off the planet. This record was set when 6 members of the Virgin Galactic Unity 25 Spaceship 2 crew happened to be in space at the same time as 3 Chinese taikonauts living and working aboard Tiangong, and 11 astronauts on board the International Space Station. Now that's getting crowded. Well, the International Space Station has always hosted the majority of space travelers from Earth, but I bet there are some cool facts about this marvel of technological development you haven't heard yet. The ISS is the 3rd brightest object in the night sky. And the coolest thing, You can sign up for a special service, and you'll get a text every time the ISS travels right over your location and is visible with the unaided eye. I've seen it dozens of times myself, and it's very, very cool. Normally, you can see it between dusk and dawn. But be ready because the station is very fast. It moves at a speed of 8 kilometers per second and circles our planet every 90 minutes. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 110 meters long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view from their special bay window. Now to the nitty-gritty. On the ISS, you wouldn't have to deal with lots of disgusting smells. There is a specially trained person who smells everything astronauts take with them to space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kind of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 0.5 kilograms of load to the International Space Station costs up to $10,000. That's why it's easier to throw your clothes away when they get dirty than to waste water washing them. While sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head, and you'd get oxygen deprived. And that's not good. People often think that in space, you experience zero gravity. Hence, the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth, and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged, but microgravity, which means itsy-bitsy gravity. Earth's gravity on the space station is only around 10 to 12% weaker than the gravity on the planet's surface. But astronauts are constantly in free fall. The spacecraft, people inside, and all the objects aboard keep falling forward. Not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. But our space exploration plans are much more ambitious than just orbiting our planet on board the International Space Station. We're preparing to send a mission to the Moon and build a colony on Mars. Some experts claim that in the next 25 years, around 20,000 people are likely to leave Earth. But how many people would it take to colonize an entire star system? In 2002, anthropologist John Moore from the University of Florida stated that a spaceship with 150 passengers could leave Earth and set off on a several thousand years journey to another star system. And upon arrival, the descendants of the original crew could build settlements in a new world. That seems like a lot of work to me. Let's continue. The nearest star system, Proxima Centauri, is 4.2 light-years away from our home planet. Talking about space, it's just next door. But for us, it's so far that we would need to build a generational spaceship to get there. But the question is how many people you'd need to send on such a mission to have enough genetic diversity. A new study disagrees with John Moore, claiming that it must be way more than 150 people. According to a scientist from Portland State University, a spaceship traveling to such a distant world would have to carry at least 10,000 people. This number might secure the success of the mission. 40,000 people would be even better. Who knows what could happen to the travelers during such a challenging and unprecedented journey? At the moment, NASA isn't ready to send humans even to Mars, let alone a distant solar system. But a few private organizations are working on this project. They hope to make interstellar trips possible in the next century. they count on a huge increase in propulsion speed, which could potentially reduce the travel time between stars to a mere few hundred years. Researchers have built several simulations to figure out how many various scenarios could play out during such an interstellar mission, and they have come to the conclusion that the success of this mission would greatly depend on the size of the starting population. Genetic diversity would keep the travelers healthy. The larger the population is, the more diversity it has. And 150 people is definitely not enough to maintain genetic variations. Even a population of 500 people wouldn't be sufficient enough. At the same time, if we sent to another solar system 40,000 people, we would be able to maintain 100% of the variation. Even 10,000 travelers would make the scenario relatively stable,